Hello everyone, today we are going to talk about basics of functions and their graphs. If we take a function that is a type of relation, so first of all we are going to see what's a relation. Relation between two sets is a collection of ordered pairs containing one object from each set. And also we can define a relation as any set of ordered pairs. If we take relations and functions, both have domains and ranges. The domain is the set of all first elements of ordered pairs, and the range is the set of all second elements of ordered pairs. Let's see one example. Here we are going to determine the domain and range of this relation. We know that the domain is set of all first elements, and we know that the range is the set of all second elements. So in this case, the domain is the set of 1.1, 2.2, 3.3, 4.4 and 5.5. And range is set of all second elements. The elements are 6, 5, 4, 3 and 2. Now we are going to define the function. If we take a relation that is allowed to have one object in first set to be related to more than one object in the second set. But if we take a function that is allowed to have one object in first set to be related to exactly one object in the second set. And if we take a relation between two sets x and y, now we can see one is related to D, 2 is related to C, 3 is related to C. In here, since each element is related to exactly one element of y, we can define this relation as a function. In here, we need to determine whether this relation is a function or not a function. Here we can see 2 is related to 1, 4 is related to 3, 6 is related to 5, and 8 is related to 5. So, no two ordered pairs in the given relation have the same first component and different second components. So, we can define this relation as a function. Now we are going to define functions as equations. If an equation is solved for y, and if we can obtain more than one value of y for a given x, then we cannot define y as a function of x, because y is related to more than one values. Here we are going to determine whether the equation defines y as a function of x. The equation is x squared plus y squared equal 1. First of all, we need to solve this one for y. To solve this one for y, first we take this x squared to other side, and that becomes minus x squared. And now y squared is equal to 1 minus x squared. To get the value of y, we take the square root of both sides. After taking the square root of both sides, we will have y equals to plus or minus square root of 1 minus x squared. Now we can see y is related to two values of x. So this is not a function. We cannot define y as a function of x. To represent a function, we use the notation f of x. Also, we can call this f at x, that represents the value of the function at the number x. Now it is given that the function f of x is equal to x squared minus 2x plus 7. We are going to evaluate f of minus 5. In this case, now x is equal to minus 5. So to calculate the value of f of minus 5, we need to take x equals minus 5. Now f of minus 5 is equal to minus 5 squared minus 2 times minus 5 plus 7. And we have minus 5 squared is equal to 25, minus 2 times minus 5 equals 10 plus 7. The answer is equal to 42. Therefore, f of minus 5 is equal to 42. If we take a function, we can represent that using a graph. The graph of a function is the set of all points xy in the plane that satisfies the equation y equal f of x. In here we are going to graph two functions, f of x and g of x. To graph these two functions, first we have to select integers for x. Here we are going to select integers for x starting with minus 2 and ending with plus 2. So integers are minus 2, minus 1, 0, 1 and 2. First of all, we are going to start with the function f of x, that is 2x, and we calculate the values of y, the related with x values. And also after that we create a table for g of x and we calculate the values of y related to 2x minus 3. After that we can plot these points on the plane and we connect them. And also for gx we plot these points on the plane and we connect them. Now we are going to see the vertical line test for functions. In mathematics, the vertical line test is a visual way to determine if a curve is a graph of a function or not. We know that a function can only have one output y for each unique input x. Let's see one example. Here we are going to use the vertical line test to identify graphs in which y is a function of x. After drawing a vertical line, if a vertical line intersects more than once, then for one value of x, the curve has more than one value of y. In this case, we define this graph is not a function. And if intercepts only once, then we can define this graph is a function. If x has two values of y, always we define that graph is not a function. And if x has only one value of y, then we can define that graph is a function. Here we are going to find the value of f of 1.5. In this case, we can see the value of x is equal to 1.5. So here we have x equals 1.5. So we are going to read the value of f of 1.5. That's equal to 3. So f of 1.5 is equal to 3. Now, for what value of x is f of x equals 0.5? Now 0.5 is the value of y. So here we have the y equals 0.5. And on the graph we can see 0.5 is related to 2. So we know that f of 2 is equal to 0.5. So the value of x is equal to 2. Then we are going to identify the domain and range from a function's graph. To find the domain of a function from its graph, we take all inputs on the x-axis. And to find the range of a function from its graph, we take all the outputs on the y-axis. Now we are going to define the domain and range of this graph. We know that to define the domain, we take all inputs of x-axis. If we take the graph, we can see inputs are 1 to 3. So the domain is 1 to 3. And to define the range, we take all outputs of y-axis. We can see the y values are 1 to 9. So in this case, the range is 1 to 9. And also we are going to identify the intercepts from a function's graph. To find the x-intercepts, we need to look for the points at which the graph crosses the x-axis. And to find the y-intercept, look for the point at which the graph crosses the y-axis. If we take a function that can have more than one x-intercept but at most one y-intercept. In this graph, we are going to identify the x-intercept and y-intercepts. Now here we can see x-intercepts are these 2 points. So we define these 2 points -1, 0 and 1, 0. In these 2 cases, the y values are equal to 0. And here we can see we have only y-intercept. So this point is 0 minus 0.5. If we take the y-intercepts, always the x values are equal to 0. Thank you.